What if I told you that the first cities on Mars won't be built with materials shipped from Earth, but from the very ground and air of the red planet itself? It sounds like science fiction, but researchers in Australia have just unveiled a groundbreaking plan to do exactly that. They're developing a way to forge iron on Mars, and it's a game changer for the future of humanity in space. Getting anything from Earth to Mars is incredibly difficult and mind-bogglingly expensive. Every single kilogram we launch costs thousands of dollars, takes months to arrive, and has a significant environmental footprint. If we want to build habitats, landing pads, or even simple tools on Mars, shipping all that metal from home is simply not an option. But what if we could become Martian blacksmiths? A team of researchers led by Professor Akbar Ramdani at Swinburne University in Australia has published the first detailed study of its kind, outlining a process to make metal on another planet. And the ingredients are beautifully simple: Martian soil, sunlight, and the thin Martian air. Here's how it works. Step 1. Make oxygen. First, you need oxygen. It turns out, this is already happening on Mars. NASA's Perseverance rover carries an instrument called MOXIE. Think of it as a small, robotic tree. It inhales the Martian atmosphere, which is 96% carbon dioxide, CO2, and breathes out pure, breathable oxygen. This process has been successfully tested on Mars multiple times. But when MOXIE makes oxygen, it also produces a byproduct, carbon monoxide, CO, gas. For years, this was just considered exhaust. But for the Australian team, that waste gas is a treasure. Step 2. Turn gas into a key ingredient. The new process captures that carbon monoxide. By cooling it down, they can create solid carbon. This carbon becomes the secret ingredient for making iron. Step 3. Add Martian dirt and sunshine. The Martian soil, or regolith, is rich in iron oxide, what we know on Earth as rust. The plan is to use a system of mirrors to concentrate the faint Martian sunlight into a powerful beam, creating a solar-powered furnace. This furnace heats the iron-rich soil, and then the carbon produced from the rover's exhaust is introduced. The carbon rips the oxygen away from the iron oxide, leaving behind pure, metallic iron. And the best part? The oxygen that's released in this stage can also be captured and used. So, you have a system that works in perfect harmony with the future oxygen factory, creating two of the most vital resources we'll need on Mars: oxygen to breathe, and iron to build. This is a monumental leap in the field of in-situ resource utilization, or ISRU, the art of living off the land on another planet. It's the key to making space exploration sustainable, cheaper, and far more efficient. Professor Ramdani, who is now collaborating with Australia's National Science Agency, CSIRO, to take this to the next level, puts it perfectly. He said, "If we want to build a large structure on Mars without launching everything from Earth, like large satellites, a Martian colony, or a refueling station, this could be a very valuable process." So, the next time you look up at the night sky, don't just picture a desolate red rock. Picture a world where Martian dust and air are being forged into the foundations of our future. We are on the cusp of not just visiting Mars, but of truly building a presence there. What do you think is the first thing we should build on Mars using this technology? Let us know in the comments below. If you want to stay ahead of our journey to the stars, make sure to hit that like button and subscribe for more looks into our cosmic future.